One aspect of the Autoflight system is the assistance provided to the pilot to keep the flight safe and within the flight envelope. This assistance covers the engine failure compensation, the low speed protections, and the autopilot flight director mode reversions. We will look at these protections in detail. In case of an engine failure with the autopilot on, the FMGS ensures automatic compensation in all modes. The primary computer is the FAC. Using the yaw damper during takeoff and go-around, and automatic rudder trim in all other phases, the FACs will attempt to maintain a zero roll rate. Also, the SRS pitch mode automatically adjusts the reference target guidance speed in case of an engine failure at takeoff or go-around from V2 plus 10 knots, or existing speed, to V2. The beta target is also activated. The slip indicator, normally yellow, turns blue and provides additional guidance to the pilot. Activated when the aircraft is in the takeoff or go-around phase, flaps 1, 2, or 3, and thrust set at a high level, it provides visual cues as to how the system is compensating for the engine loss. Low speed protection is achieved by the following features: the auto throttle speed mode, the low energy warning, the angle of attack protection, alpha protection, the alpha floor protection, and the wind shear protection. When the auto throttles are on and in speed mode, if speed is in the managed mode driven by the FMGS and the speed target is below the maneuvering speed for a certain configuration, here the minimum speed for flaps 2, the system will not allow the speed to decrease below this maneuvering speed. If the speed is in the selected mode by the pilot on the FCU and the speed target is below VLS, the system will not allow the speed to decrease below VLS.
Speed, speed, speed.
If the auto throttle system is off and the speed drops below VLS, turbulence, wind shear, inattention, a repetitive speed, speed, speed oral warning is automatically triggered by the FACs. The warning is intended to divert attention to the speed scale with a subsequent thrust adjustment. This warning takes into account the aircraft deceleration rate and current flight path angle, which explains the low energy wording. Power must be added to correct the situation. The warning is armed on both departure and arrival between 100 feet and 2,000 feet RA with flaps at 2, 3, or full. If the speed continues to drop below the low energy warning, and if the angle of attack increases above a given threshold, the alpha floor function of the autothrottle system triggers, and toga power is commanded. The angle of attack threshold, which triggers alpha floor, is processed by the FACs as a function of aircraft parameters, such as configuration, deceleration rate, angle of attack, etc. Much of this information is derived from the IRs. When alpha floor is triggered, the auto throttles are turned on if they were previously off, indicated by a white A/THR on the FMA. A floor in green is displayed as the auto throttle mode. The alpha floor function is available from liftoff down to 100 feet AGL.
Wind shear, wind shear, wind shear.
If the FACs detect wind shear conditions, a red wind shear message is triggered on both PFDs, along with an oral warning, wind shear, wind shear, wind shear. Wind shear detection is available from liftoff to 1,300 feet at takeoff, and from 1,300 feet down to 50 feet during landing, provided the aircraft is in configuration 1 or higher. Wind shear protection is provided during takeoff and go-around when SRS is active. SRS will command a pitch angle which ensures a minimum positive rate of climb despite a potential speed loss. However, if the angle of attack becomes too high and reaches angle of attack protection, the autopilot, if engaged, trips off. AOA protection allows the pilot to achieve the best angle of attack while preventing the aircraft from stalling. The stick can be pulled all the way back without fear of stalling. Wind shear protection is also provided in the approach mode when managed speed is engaged. The target speed, V approach, is automatically adjusted with wind variations, ensuring that the ground speed does not drop below a minimum value, referred to as mini ground speed. This protection is absent if the system is in selected speed. We will now review the mode reversions of the Autopilot Flight Director and Autothrust systems. The mode reversions are automatic mode changes which ensure a flight envelope limit protection and which allows a uniform response from the system when there is pilot input on the FCU. Let's review the flight envelope limit speed protection with the autopilot on. You are in climb. The target speed is 315 knots, and you select a vertical speed of plus 3,000 feet per minute. The performance capability of the aircraft does not allow such a high rate of climb. The autopilot pitches the aircraft up to track the vertical speed. The autothrust system, still in the speed mode, gradually increases thrust to max climb, since the speed is decreasing. When the speed decreases to VLS plus 5 knots, the autopilot vertical mode reverts to open climb and the autothrust mode to thrust climb. The autopilot will pitch the aircraft down to re-accelerate toward the 315 knot target speed. This reversion ensures the flight envelope low limit speed protection. Suppose that during a descent we inadvertently set a vertical speed of plus 3,000 feet per minute. The target altitude is below us, but the aircraft is climbing. Note the lack of the armed altitude capture, blue, on the FMA. Again, the aircraft pitches up to plus 3,000 feet per minute, and again the speed decreases. When the speed reaches VLS plus 5 knots, the autopilot vertical mode reverts to open descent and the autothrust mode to thrust idle. Remember, with the target altitude above aircraft altitude, the reversion is to open climb thrust climb. With the target altitude below aircraft altitude, the reversion is to open descent thrust idle. Here's another example. We are descending 3,000 feet per minute. The target speed is 250 knots, and the target altitude is below us. The high rate of descent causes the aircraft to accelerate. When the aircraft speed reaches VMO plus 5 knots, the autopilot vertical mode reverts to open descent and the autothrust mode to thrust idle. The autopilot pitches the aircraft up to recapture the 250-knot target speed. This reversion ensures the flight envelope high-limit speed protection. Depending on aircraft configuration, gear, and flaps, this reversion can occur at VLE plus 4 knots or VFE plus 4 knots. Here is another reversion. We are on approach in landing configuration, but high above the glide slope. We select a vertical speed of minus 2,500 feet per minute. Notice that the vertical speed needle is red, meaning the rate of descent is unsafe. Also notice that the altitude on the FCU is above the actual altitude. Again, the high rate of descent causes the aircraft to accelerate. When the aircraft speed reaches VFE plus 4 knots, the autopilot vertical mode reverts to open climb, and the auto thrust mode to thrust climb. This is because the FCU altitude is above the actual altitude. Also, an automatic pitch-up occurred when high-speed protection was triggered. Lastly, the system is also trying to recapture V-approach. Sort of spoils your approach. The lesson: if you are high above the glide slope, do not use an excessive vertical speed. We will now review other limit speed protections relating to manual flight. Autopilot off. You are manually flying the aircraft in a descent using the flight director and the auto thrust. The current modes are open descent and thrust idle. We now pitch the aircraft up, disregarding the flight director orders. The speed decreases. When the speed reaches VLS minus 2 knots or VLS minus 17 knots with speed brakes extended, the auto thrust reverts from thrust idle to speed, and thrust is readjusted to capture the target speed, or VLS, whichever is higher. Simultaneously, open descent reverts to vertical speed using the actual vertical speed at the time of reversion. This time we are in climb, with open climb and thrust climb engaged. Once again, we will not follow the bars, but will keep the pitch lower than what is needed. The speed increases. When the aircraft reaches Vmax plus 4, auto thrust reverts from thrust climb to speed, and thrust decreases to recapture the target speed. Simultaneously, open climb mode reverts to the current vertical speed. Depending on configuration, gear and flaps, this reversion can occur at VLE or VFE. We will now look at some essential mode reversions that occur when you modify the FCU target altitude during climb or descent. These mode reversions are designed so as not to change the aircraft pitch when new altitude selections are made. It leaves it up to the pilot to decide how to continue. We are climbing to flight level 250 using either open climb or climb, when ATC requests that we level off at flight level 220. First, select flight level 220 on the FCU. The autopilot immediately reverts to the current vertical speed. Notice also that altitude, blue, is not armed. It is then up to the pilot to decide how to regain flight level 220 by dialing in a vertical speed, such as 1,000 feet per minute down, or by pulling the Alt selector to engage open descent. Note, you can imagine the same scenario in descent. Same scenario, we are just capturing the target altitude, Alt star green, when ATC clears us back up to flight level 250. We select flight level 250 on the FCU. Once again, the autopilot reverts back to the current vertical speed. Again, it is up to the pilot to decide how to regain altitude target, by pulling the altitude selector to engage up climb, or by selecting a vertical speed.